Good evening, ma'am.
Good evening. Hariharan, go see the questions and see whether you can find the answers
Okay, ma'am.
for the time that we are waiting for others to come. Hello, Vaishnavi.
Hello, ma'am.
Vishal, how are you? Okay, so we'll start now. 4 of you are there, so 3 of you. So we can do a few questions while we wait for the others to come. So look at the first question. Those who don't come don't get to revise. So addition of water to alkynes occurs in acidic medium and in presence of Hg2 plus ions as catalyst. So in the last class, we did this reaction where we are trying to prepare aldehydes and ketones from alkynes. Which of the following products will be formed on addition of water to 1-butene? What will you get when you add water to 1-butene? What is the correct answer? Who will tell me? Hariharan, you got a lot of
Butanol, ma'am.
butanol.
Butanol, ma'am.
Yes, correct. Right? Because the only aldehyde that we get is acetaldehyde or ethanol You don't get this, you don't get an acid, and you don't get mixture of aldehydes of butanol. Now, the next person who came in was Vaishnavi. Vaishnavi, tell me what is the answer for this next one. Which of the following is most reactive toward nucleophilic addition reactions? Vaishnavi?
Ma'am, is it second one?
No, actually, you should remember aldehydes are more reactive than ketones, first of all. And as the size of the alkyl group increases, the reactivity decreases. So the first one, this is the most reactive. Okay, this will be the most reactive. And on ketones also, if you are comparing ketones, as the size of the alkyl group increases, the reactivity decreases. Okay. Compounds A and C in the following reaction are, what are A and C? Are they identical? Are they positional isomers, functional isomers, or optical isomers? Okay, so let us see what is A. Can you tell me what is A? Vishal, did you attend my last class? Vishal,
Yes, mom.
did you attend my last class?
No, mom. I was absent on my last class.
So you should, Vishal, you have to be very regular, otherwise you will all, if you don't attend the first class when the topic is introduced, you miss out a lot. So you have to be very careful. You should attend all the classes.
Okay. No, mom.
Okay.
Actually,
Now,
I
Sai
had a
Kalyan, tell me,
class.
what is A? Can you? I can't hear. Tell me. What is A? Can you make out? Sai Kalyan, what is A? CH3CHO plus CH3MgBr in presence of H2O. What will you get first? Sai Kalyan, can you guess what you will get? Are you there, Sai Kalyan? Hello. Hariharan, can you tell me?
Alcohol, ma'am. Secondary
Which
alcohol.
Very good. You will get the secondary alcohol. CH3CHOH. Secondary alcohol. Now, when you treat the secondary alcohol with H, so this is A. Now, when you treat the secondary alcohol with B, with heat with H2SO4, what will you get? CH3, CH, double bond, CH2, dehydration. This is D because of elimination of water. And then when you do hydroboration oxidation, B2H6 in presence of OH minus, water will add again and you will get 1-propanol, right? So this is C. Now A and C, what are they? They are position isomers. So what is the answer? A and C are position isomers, positional isomers. Okay. Sai Kalyan, are you there? Sai Kalyan, hello.
Yes, miss.
Okay. So the next question Sai Kalyan has to answer. Okay. Which of the following compounds will give butanone on oxidation with KMNO4 solution?
Miss, option 2, miss.
Option 2. Very good. The first one will give what? The first one will give, it is a primary alcohol, so it will give butanol, butanal. Second one will give butanone, right? Then addition of HCN to carbonyl compounds is an example of. Now, Vaishnavi, can you answer that? Addition of HCN to carbonyl compounds is an example of.
Ma'am, is it nucleophilic substitution?
See, what is a carbonyl compound, Vaishnavi? It has C double bond O, right? So when there is reaction taking place across carbon and oxygen, carbonyl group, what type of reaction can it be? It has to be nucleophilic, but what will it be? Nucleophilic addition. Not substitution, it is nucleophilic addition. Ozonolysis of 2,3-dimethyl-2-butene. Somebody came and went. Who was that? I couldn't see. Okay, so ozonolysis. Now, Hariharan, you
Doing, ma'am.
answer. Ozonolysis of two. Which one?
I'm doing, ma'am.
Okay. Do it. 2,3-dimethyl-2-butene. This is the compound. So if I do
And then we get a
ozonolysis,
C, ma'am. Option C, ma'am. 2 molecules of propanol, ma'am.
why 2 molecules? Not propanol. It is 2 molecules of acetone. Actually, acetone, you have to remember, it is also, acetone is the common name of the compound which is known as propanone. Okay, so 2 molecules of propanone, which is also known as acetone. Okay, so you have to remember the common names also. Now the next one, who will answer now? Oh, somebody else also went. Sai Kalyan, can you tell me the answer of the next one? Which of the following is a major product from the reaction, which is given here? Which is the major product? This is a reaction of
Option B, miss.
ammonia derivatives, NH2CO and
Option B, miss.
this one is a tricky question. So I should show you this one. So it is, I will write there so that you do not make a mistake in your answer. So this is your acetone, CH3, C double bond O or propanone. And it is reacting with, NH2G. So H2N you write here. And then you write the G. What is G? NHCO, NH2. Right? So this water goes. So what do I get? CH3 whole twice C double bond N, NH, CO, NH2. Okay. So double bond N, NH, CO, NH2. So the answer is actually D. Okay. Now the question, in this question, the trick here, the trickiness of this question is that there are NH2 here and NH2 here. You have to look at the this NH2 will give the hydrogen. This is the G which is attached to that NH2. Okay. This NH2 is not the one. So this is the NH2. So it is a derivative of NH2, NH, CO, NH2. That is a compound and it is deliberately written reverse so that you make a mistake. So the answer is D. Be careful here. Then Hariharan. Which of the following is more reactive towards nucleophilic addition reactions? This question is already asked once now. Which will be the most reactive? Tell me.
C, ma'am. Option C.
Why C?
Because it's
The
aldehyde, ma'am.
No, because as the lower aldehydes are more reactive. So the most reactive is formaldehyde. Most
Less
reactive
bulky
is
groups, ma'am.
less bulky groups. Where the group becomes more bulky, the reactivity decreases. All right. That is why ketones are less reactive than aldehydes. Ketones can be obtained in one step by, how can you obtain ketones in one step? In one step, you
Secondary
can,
alcohol.
yeah,
Oxidation.
you can
Secondary alcohol.
oxidation of secondary alcohols. Very good. Now we will continue with what we were doing in the last class. In the last class, we were doing one special reaction, which I called aldol condensation. Okay, so
Miss,
we did two. Yes, tell me.
Miss, last half an hour, 40 minutes of the class can you give a revision on electrochemistry?
Electrochemistry, yes, I can. I will give you a revision on electrochemistry. When is your test on electrochemistry?
Tomorrow, Miss.
Oh, we'll do a revision on electrochemistry, sure. Okay, so so we will have this class up to 7:10, and from 7:10 to 7, no. Okay, I will give, don't worry. I'll give a revision. We'll plan it. So my class is from 6 to 7:30. So 7 to 7:30.
Questions, Miss, no need to explain this questions like that.
Yeah, just a few things, just the formula and a few questions we'll do.
Okay.
Okay, so in the last class, we were doing this important reaction, which I told you is the aldol condensation. Okay, so what is the speciality of aldol condensation? We'll quickly go through it. It is a bimolecular reaction. It is shown by aldehydes and ketones, which have alpha hydrogen. And at least one molecule of the two molecules should have a alpha hydrogen. Then this is the one which happens in presence of a dilute alkali, and the product is a aldol, right? Then we talked about how the aldol condensation happens. So it is the alpha hydrogen, which is just like addition reaction. It adds on and you get first the addition product, which is aldol, which loses water and it gives you a unsaturated aldehyde or ketone. So we did several examples, one with formaldehyde and acetaldehyde. So you have noticed here, there is no, in the first one, there is no alpha hydrogen. In the second one, there is. So of the two molecules, the one of the two molecules should have alpha hydrogen. So we did several examples, and now to close it, we can do one more so that you can get an idea, and it can be a revision for you. So the last one of aldol, crossed aldol condensation, we can do C6H5CHO. Okay. Now this one does not have alpha hydrogen, and I want to react it with ethanol. So CH3CHO. So I've written as CH2 HCH2CHO, so that you can see the alpha hydrogen clearly. So where will the alpha hydrogen go? This is negative and this is positive, and this is negative and this is positive. So you can add the two and write the product. So what do you write? C6H5CH, and whenever you add hydrogen, that O will come down and hydrogen adds there, and this one becomes CH2CHO. Okay, so this is the aldol. Okay, the aldol that you get. So you have a OH and a CHO, so it is aldol. Now it will lose water. How will it lose water? OH here and H here. So what will you get? C6H5CH double bond CHCHO. Okay, this is called cinnamaldehyde. I am telling you its common name. You can give it IUPAC name also. I'm telling you the common name because this is the aldehyde which gives flavor to cinnamon. What is cinnamon? You know, cinnamon is a very important spice, which is the bark of a tree, and it is used in what you call garam masala. I don't know what you call it in Tamil. Vaishnavi, do you know what cinnamon is known in Tamil? In Malayalam, we call it patta, patta.
In Tamil, it's pattai, ma'am.
So it is like, those flat things, which is a bark of a tree. So it is used for making, your biryani and your fried rice and all. They use cinnamon powder. So that is because of presence of this cinnamaldehyde. So this is also an unsaturated aldehyde. So these are a few reactions of aldol condensation. All of you should write and practice these reactions. Only then you will learn them. Otherwise, it will be very difficult. Now the next very important reaction, which is just like aldol condensation, but very different from it in some ways. Then the next reaction is called Cannizzarose reaction. Cannizzarose reaction. Okay, so what is Cannizzarose reaction? Just like aldol condensation, it is also a bimolecular reaction. Okay, bimolecular reaction means two molecules of the substrate are required to take part in this reaction. So two molecules of the substrate. Then second is it is shown only by aldehyde. So it is shown by only aldehyde. Ketones don't show this reaction, only aldehydes. And which aldehyde? With no alpha hydrogen. In the last one, what were we looking at? Aldehydes which have alpha hydrogen. This is with no alpha hydrogen. So in our syllabus, which are the two aldehydes which we have to think about? HCHO. Okay, methanol, HCHO, or methanol or formaldehyde, and C6H5CHO, that is benzaldehyde. These are the two basically aldehydes which will not show, which do not show aldol, but they show Cannizzarose reaction. So with no aldehydes, which aldehyde? With no alpha hydrogen. Third important thing is it happens in presence of concentrated KOH or concentrated NaOH, concentrated alkali. In the previous case, what was the case? It was dilute alkali. Here it is concentrated. The fourth thing is what is the product there? There the product was easy to remember. It was aldol. Here what is the product? Here the product, there are two products. One is an alcohol and the other is an acid salt. Okay, alcohol and acid salt. Okay, so let us see the examples of this. So supposing my aldehyde is, first example, supposing my aldehyde is HCHO. So bimolecular means two molecules of HCHO along with NaOH. Okay, so what will I get? The product which I get will be an alcohol, which alcohol? An alcohol which is formed by reduction of formaldehyde. So I have told you always aldehydes come in the middle. Above them are alcohols, below them are acids. So if my aldehyde is methanol, then which alcohol will it form? Methanol. So CH3OH. Alcohol with same number of carbon atoms. And which acid salt it will form? It will form an acid with one carbon atom. Which is that acid? HCOO and H. That is methanoic acid. But because there is NaOH, it will form sodium methanoate. So what are the two things? Methanol and sodium methanoate. Okay, acid salt of which acid? Methanoic acid. And you started with what? Methanol. Okay. Now the second example, let us take C6H5CHO. So bimolecular, so again C6H5CHO. And I will this time use KOH. So what will I get? I will get an alcohol. Alcohol which you will get by reduction of benzaldehyde. So what is alcohol? It will be benzyl alcohol. Same number of carbon atoms, so CHO will become CH2OH. So what is this? benzyl alcohol. And what is the other one? C6H5, you will get benzoic acid, C6H5COO. And because it is potassium hydroxide, so this is potassium benzoate. Okay, so this reaction, it is known as which one? Cannizzarose reaction. You have to remember very clearly and understand very clearly is that the alcohol and the acid salt which are formed, they will have same number of carbon atoms as the aldehyde that you started with. Okay, so that is. Now the next reaction that you need to understand here is crossed Cannizzarose reaction. Crossed Cannizzarose. What is the meaning of crossed aldol? Crossed aldol, when in the bimolecular reaction there were two different aldehydes or ketones. So this is crossed Cannizzarose reaction. In case of crossed Cannizzarose reaction, what do? We take two different aldehydes, both which do not have alpha hydrogen. So this time I will take C6H5CHO, one molecule. The other molecule I will take HCHO. And along with that, let us take NaOH. I can take KOH also, doesn't matter. So one molecule will get reduced. So if there are two, always formaldehyde is more reactive, it gets oxidized more easily. And so this one will form the alcohol C6H5CH2OH, and the other one will form the acid salt. So this becomes what? This becomes a crossed Cannizzarose reaction. The mistake which children make is they instead of writing C6H5CH2OH, they write C6H5OH, which is not alcohol, which is a phenol. And moreover, the number of carbon atoms should be the same. So here there is C6H7 carbon atoms. Here also there should be 7 carbon atoms, and this is Cannizzarose reaction. So I hope you understood aldol condensation and Cannizzarose reaction both clearly. Now comes the last two reactions here. They are, first one of them is oxidation reaction. Okay, oxidation reactions. Oxidation reaction. Now, before I do oxidation reactions, please remember very clearly, right? You have to remember that where is your aldehyde? RCHO is my aldehyde, right? So what is my functional group? Let me rub it out and write it with a color. There is R is there, and then this is CHO, RCHO, right? Now if I do oxidation of this, okay, if I go right, I'm doing what? Oxidation. Aldehydes are in the middle. If I do go to the right, I do what? Oxidation. So R will remain as it is, and what will happen to CHO? It will become COOH, right? It will become an acid with same number of carbon atoms. So R is there, CHO changes to CO. If I go backwards, then what am I doing? Then I do reduction H. Then I do reduction, right? If I do reduction, then what do I get on this side? R is there, but CHO changes into what? It changes into CH2OH. Okay, so you have already learned that from alcohols on oxidation, I get aldehydes which get oxidized into acids, right? But if you go backwards from alcohol, aldehydes, you get alcohols. And if you go forward from aldehydes, you get acids. So you have to remember this combination. So now we are talking of oxidation reactions. Remember, these aldehydes, they get oxidized very easily into acids. But remember, the number of carbon atoms remain the same. So let us take an example. If R is H, R is equal to H, then what will I get? let me write here. This is CHO and this is COOH. Again, CHO and here COOH. Right? And once more, I will write CHO and COOH. And I'll change my R. So how do I change my R? In the first case, I make it HCHO. Then oxidation will give me what? HCOOH, right? So this is what? Methanol. And on oxidation, what will it give? Methanoic acid. Methanoic acid. Now, if I write here CH3CHO, what will it become? Ethanol. And on oxidation, what will it give? Ethanoic CH3CHO. So what will it become? Ethanoic acid. Right? And if I make it CH3CH2, what is it? Propanol. Right? Then on oxidation, what will I get? Propanoic acid, C2H5, let me write it. So propanoic acid. So depending on your aldehyde, just look at CHO group and change it into COH and that is a product. But you have to now learn what are the various oxidizing agents that we can use. So there is a large number of oxidizing agents which can bring about this reaction. So let us talk about the oxidizing agents. Which oxidizing agents? Which can convert? What type of oxidizing agents are they? They can change CHO to COOH. So first among them is Tollens reagent. It is known as Tollens reagent, right? So what is Tollens reagent? Tollens reagent you will use in the lab for identifying the aldehydes. You will always make use of the Tollens reagent. So Tollens reagent is actually ammoniacal AgNO3. Okay, it is ammoniacal silver nitrate. And this reaction is very useful. This one is a mild oxidizing agent. It is not a very strong oxidizing agent. It can only convert aldehydes to acid. It cannot oxidize any other compound. So it is a mild oxidizing agent and it gives a very interesting observation. So if you take an aldehyde and you add Tollens reagent to it and you heat it, then a silver mirror is deposited on the walls of the test tube. The test tube will start looking silvery. I can show you a picture of that. I should have kept it ready. Just 1 minute. It will take 1 minute. I'll just show you the picture. Hmm. See, this is the picture. You can see the test tube becomes silvery. This is how the test tube becomes, silver is deposited on the walls of the test tube. The test tube becomes so shiny when you put the test tube in the water. Silver is deposited on the walls of the test tube. This is known as the silver mirror test. Okay, and this test is used as a distinguishing test. Okay, in every exam, there are two tests which are asked. So this is one very common distinguishing test. So you can distinguish between aldehydes and ketones using this test, because only aldehydes give this test, ketones do not give this test. Distinguishing test to distinguish between aldehydes and ketones. So all aldehydes give this test, but none of the ketones will give this silver mirror test. Now, how do we write the reaction? Now, reaction here is a little complicated. You will have to memorize it. There are easy ways of writing, but then, they are not accepted in your report. So you will have to learn this long reaction. So if I write a general reaction, RCHO plus ammoniacal silver nitrate. So you can write it as AgNH3 twice. This is a complex of silver. Okay, square bracket means it's a complex ion, plus 3 OH minus. Okay, I'll try to give you some easy method of learning it, but right now this is the equation. So this will give you RCOO minus. That is, you get the RCHO is changing into RCOOH. It is an ionic equation. That is why they have written it like this. Plus 2Ag plus 2H2O plus this I'll have to make it twice plus 4NH3. So this is the equation, which is the reaction that you can write for tolerance reagent. The easy way of writing is, supposing you forget this reaction, then to save, at least you will get half a mark, if not the full mark. You can write like this, RCHO on the arrow. I told you, you can save yourself a lot of trouble of balancing if you write the reactants on the arrow. So here you write O, which shows oxidation is happening. And here you write tolerance reagent. You can write ammoniacal AgNO3, ammoniacal silver nitrate. And then here you can directly write RCOOH. Okay. And byproduct, you must mention formation of Ag, because that is the silver which is deposited on the walls of the test tube. So this reaction has a visible observation, and that is why the reaction is very, very important and very useful. Now, similarly, you have one more reaction, oxidizing agent, the second oxidizing agent. Second oxidizing agent is known as Felling's solution. These reactions are important because you are going to use them in the lab. You are going to do these reactions in the lab to identify the aldehyde group. So both these are generally commonly done in the lab. So what is Felling's solution? So Felling's solution is a solution of Felling's A and Felling's B. Okay, Felling's A and Felling's B. Now, Felling's A is a solution of copper sulfate. It is aqueous CuSO4 copper sulfate solution. And Felling's B is alkaline solution of sodium potassium tartarate. Sodium potassium tartarate, also known as Rochel's salt. Right? Again, what is the importance of this reaction? This reaction helps, it is very often used in those medical labs where they want to find if a person is having sugar or diabetes by testing the presence of sugar in the urine, because in presence of sugar means there is glucose in the urine, and glucose contains CHO group. So if you test with this, you can find out whether there is glucose present in your urine, and if there is, then it is a test for diabetes. So phalanx A and phalanx B, you mix them together in equal volumes and you get a blue colored solution, which you call it phalanx solution. So if you take a salt, a compound which contains a CHO group, and if this one will contain copper ions, so 2Cu2 plus 5OH minus. You need to understand balancing equations in alkaline medium, then you will get the answer correctly. So you will get RCOO minus plus Cu2O plus 3H2O. Now this is a red precipitate. So from a blue colored solution, if you get a red precipitate, that means your compound is oxidized. So RCHO, if a compound contains RCHO, you will get a red precipitate. Why? Because the phalanx solution acts as a oxidizing agent and RCHO gets oxidized. So Cu2 plus changes into Cu plus, so it gets reduced and the aldehyde gets oxidized. So that is the reaction with phalanx solution. Here again, if you want to write the reaction in an easy way, the easy way for this will be you can write reaction with CuO, 2CuO, this is copper oxide, and right here RCOOH plus Cu2O, and this is the red precipitate. So this is also sometimes accepted, but many times they don't like to, they want you to write only the ionic equation, then you have to write it. So this is also a mild oxidizing agent. Now what is, why should you learn another mild oxidizing agent? This mild oxidizing agent can oxidize only aliphatic aldehydes. Aliphatic aldehydes. That means it can be used to distinguish between benzaldehyde and formaldehyde. Okay. So benzaldehyde will not give this test because it has a benzene ring. It is aromatic aldehyde. So where can be used to distinguish between HCHO and C6H5CHO. So this will give a red precipitate and this will not give a red precipitate. So you can distinguish using phalanx solution. So this is another good oxidizing agent that can be used for oxidation. Then if you can use strong oxidizing agent, you can weak oxidizing agents, you can also use strong oxidizing agent. I have already told you the oxidizing agents which we use for alcohols, you know, they are concentrated H2SO4 and dilute H2SO4 and potassium dichromate or alkaline KMNO4. All these are very good oxidizing agents which can not only oxidize aldehydes to acid, they can actually oxidize alcohols to acids. So they can obviously oxidize aldehydes. Now there is a very interesting question here, and that question is oxidation of and that is known as iodoform reaction. Iodoform reaction. This is also used as a reaction. It's a very important reaction. It comes under oxidation of aldehydes. And this reaction can oxidize the aldehyde into a corresponding acid salt. Okay. Now this reaction, iodoform reaction, is shown by all those compounds which have a CH3CO group. So this is what is the speciality of this reaction? It is shown by compounds containing methyl keto group. Okay, what is a methyl keto group? Methyl keto group is CH3C double bond O group. This should be present. Now this should be not only this should be present, it should be a part of an aldehyde or a ketone. That is important. Should be a part of a aldehyde or a ketone. Why I am saying this is, which are the compounds which will show this reaction? It will be shown by CH3, C double bond O and H. What is this? Ethanol. It can be shown by CH3, C double bond O and CH3. What is this? Propanone. Right? It can be shown by CH3, C double bond O, CH2, CH3. It is butanone. Right? And 2-pentanone also can show this reaction. Right? So these are all compounds which have which group? Aldehydes and ketones, and they contain what? The methyl keto group. So any compound which has a methyl keto group can show this compound. Now, which are the ones which cannot show? So this can show, this can show, this can show. Which cannot show? Supposing I take CH3, C double bond O and OH. This also has a methyl, this CH3CO group. Right? CH3CO group. So this CH3CO group is not a methyl keto group. Here it is known as the acetyl group. Right? So this cannot show. This is not a part of an aldehyde or a ketone. It has a methyl keto group, but this will not show. Similarly, if I write CH3, C double bond O and Cl, it also appears to have this group, but this cannot because it is not an acid or aldehyde or a ketone. It is an acid derivative. So when it's a part of acidic group, then it is called the acetyl group. So this also cannot show. So you have to be very careful. So which are the compounds? All ketones which have carbonyl group on the second carbon, or among aldehydes, only acetaldehyde can show this reaction. So that is about who can show. Now the second important point is what are the conditions. This reaction happens in presence of NaOH and iodine. NaOH and iodine. And what is the product in this reaction? The product in this reaction is first important product. Let me write it with yellow because it is a yellow crystalline precipitate, CHI3, and this is known as iodoform. Okay, what is iodoform? It is a yellow crystalline precipitate with hospital smell, yellow PPT with hospital smell. With hospital smell. Right? Now, let us learn to write the reaction. Okay, so now to understand this reaction, so I will take any compound which have, so to make a general reaction, it could be R, C double bond O and CH3, right? And in presence of, so first you write the reaction of NaOH and iodine. Okay, so NaOH and iodine, it gives you Na I and NaOI plus H2. 2NaOH plus I2, it gives you these two products, sodium iodide and sodium NaOI, hypoiodide. Okay, so this is the oxidizing agent. So in presence of NaOI, okay, this is the way it is given in your book. I can make it easier for you. So this part breaks out. So this part here, CH3I, it forms CHI3. and the rest of the molecule, it forms RCOONA. Okay, so you have to learn to break it into two. One, identify the CH3, and the other part will form the acid source. So let us take the example. Supposing it is HCCH3, ethanol. In presence of, if you don't want to write this, you can just write NaOH and I2 on the arrow. What will I get? CHI3 plus HCOONA. Supposing it is CH3, C double bond O, CH3, CH2, C double bond O, and CH3. So this part will form what? CHI3. So on the arrow again, write NaOH and I2. What will you get? You will get CHI3 and the rest of it, CH3, CH2, COON. So that is how you write the products. Now this is also literally formed by, like it is a, you can call it an oxidation reaction, but you get an acid which is one carbon atom less than the number of carbon atoms starting from the compound, but from a ketone you are getting an acid. So this reaction is known as a iodoform reaction. Where does this reaction become useful? Supposing I have to distinguish between formaldehyde and acetaldehyde, I can use this reaction because if my compound has CH3CO group, it will give a yellow precipitate of CHI3, which formaldehyde will not give. So this also can be used as a distinguishing test. To distinguish between what? HCHO and CH3CH. You can distinguish between the two using iodoform reaction. So that is about the next oxidizing agent. Okay, so we have learned three important oxidizing agents. One is iodoform reaction, one is using Tollens reagent, and the third using Fehling solution. In all of them, there is a very good visible observation. Now let us do the oxidation of ketones. Oxidation of ketones. We were doing only for aldehydes where we get acids with same number of carbon atoms. Then we did iodoform reaction, which is different for both aldehydes and ketones. Now we'll do only oxidation of ketones. So supposing I have CH3, C double bond O and CH3. And now I will do oxidation, but I need a strong oxidizing agent, strong agent. What is a strong agent? K2Cr2O7 and dilute acid. So what this does is it oxidizes, but it breaks the ketone. Right? So if it breaks it here, I will get two acids. One acid with two carbon atoms, CH3COOH, and the other acid with one carbon atom, HCOO. Supposing I had CH3, C double bond O, CH2, CH3. Right? And then I do oxidation. What will happen? It will break. It will break so that the carbonyl group remains with the smaller alkyl group. So you will get CH3COOH, two parts. Two acids, one with two and the other with also two carbon atoms. So you will get CH3COOH plus CH3CO. So ketones are very difficult to oxidize, but for oxidation, they need strong oxidizing agent. And if you get an acid, the acid will have lesser number of carbon atoms than the ketone. Here there were 3 carbon atoms, here there are 2. Here there are 4 carbon atoms, you got 2 plus 2. Okay, so the number of carbon atoms is reduced. So that is about oxidation of aldehydes and ketones. Now the last bit, after which we will revise our electrochemistry. So the last bit is reduction. Reduction of aldehydes and ketones. So I already told you about reduction. Now let us do reduction. So supposing I have both aldehydes and ketones, what do they have? They have carbon-oxygen bond. So when I want to reduce it, I can reduce it in two ways, right? So how can I reduce? I can reduce it by addition of hydrogen. So what will I do? I will add hydrogen. So it will become one H here and the other H here. So it will become CHOH. So it will become what? An alcohol. So I can reduce it to an alcohol. The other is I can remove oxygen completely and I can put two hydrogens instead, right? So it will become a alkane. So let me take special example. Supposing I have CH3 CHO. Okay. What is it? Ethanol. Now when I reduce it, what can I get? I can add one H here, one H here. So it will become CH3 CHOH. If I write in a straight line, what does it become? CH3 CH2OH. What is this? Ethanol. But if I remove oxygen, then CH3H CH2. So what will it become? CH3 CH3. So it will become what? Ethane. So depending on my reducing agent, I can convert the aldehydes into primary alcohols and or I can convert them into alkanes with same number of carbon atoms. We can take more examples. Now supposing I have a ketone, so CH3 CH3 C double bond O. What can I do with it? First I can add hydrogen, one here, one here. So what will I get? CH3 CH3 CH and OH. So what did I get? Secondary alcohol. And I can remove this and make a alkane. Which alkane is this? Propane. So I can make alkanes with same number of carbon atoms and secondary alcohols if I start with ketones. So what is a general rule that you understood? That aldehydes on reduction, okay, if I do reduction of aldehydes, I can either get primary alcohol or I can get alkanes, right? And if I take ketones and do reduction, I can get either secondary alcohol or I can get alkanes. Okay, depending on which ketone or which aldehyde I can make the product. Now let us talk about the reducing agents. There are 4 important reducing agents that we need to understand. What are the reducing agents? So the first reducing agent is NaBH4. Okay, that is a specialist. Okay, I call it a specialist. Why is it a specialist? It can only convert CHO to what? CH2OH. CHO to CH2OH. It will convert aldehyde to primary alcohol, or it can convert ketone to secondary alcohol. But it can only convert aldehydes and ketones to primary or secondary alcohol. So this is a specialist. It cannot convert anything else, only aldehydes and ketones to alcohols. The second is lithium aluminium hydride. Okay, this can do all this. CHO, it can convert to CH2OH, primary alcohol. Ketone, it can convert to secondary alcohol, right? But in addition to that, it can do a lot of reduction. It can convert COOH also to CH2OH, right? It can also convert C triple bond N to CH2NH2. So it can bring about lot of reductions. It is not a specialist, it is a general purpose. Okay, general purpose reducing agent. It almost converts everything. Wherever it can add hydrogen, it will add hydrogen to the double bond and it will change it into a reduced product. So that is lithium aluminum hydride. So you can think of two, NaBH4 or lithium aluminum hydride. Both are useful to convert aldehydes and ketones to corresponding alcohols. Now we will take two more special reducing agents. The third one is zinc amalgam, Zn and Hg and HCl. Zinc and HCl. So zinc and HCl, this is a reducing agent which can convert CHO to an alkane, aldehyde to an alkane, or a ketone also to an alkane. Okay, so if I write the reaction CH3CHO, and you have to write reducing agent 4H, and on the arrow you have to write zinc amalgam and HCl, you will get CH3CH3 plus 2H2. Plus not 2H2O, H2 only. Okay. Now this reaction is important because obviously it has a name. It is known as Clemenson's reduction. What is the importance of Clemenson's reduction? What are the important features? First, it converts aldehydes and ketones into alkanes. And secondly, it works in which medium? Acidic medium. Now the fourth one is NH2NH2 hydrazine in presence of potassium hydroxide. So these are contrasting. One you use acidic medium, here you use alkaline. But you can write the same reaction CH3CH double bond O plus 4H. But this time the hydrogen is coming from where? NH2, NH2 and KOH. Right? You will get CH3, CH3 and H2. So this also converts aldehydes and ketones into alkanes, but both one works in acidic medium, the other one works in alkaline medium. So they work in opposite medium. So if there is an aldehyde which you can't reduce in acidic medium, you use the second reaction. Otherwise, this also has a name. It is called Wolff-Kishner's reduction. Kishner's reduction. Okay, so that is about all aldehydes and ketones. I think I have finished all the important reactions. Okay, now what remains is a few reactions of benzaldehyde, which I will take specially, the methods of preparation of benzaldehyde, and a few properties of benzaldehyde that we can do in the next class. I could have finished it today, but now you want a little revision on your electrochemistry. So so we will do the revision. Okay. So we will take the electrochemistry revision. So in electrochemistry, there are the first part is you have to learn about first the galvanic cells. Okay. Now in galvanic cells, you should know how to write 4 things. Okay. First, you should know how to write the cell representation. Okay. You should understand the cell representation. So cell representation, how do you write? You should remember LOAN. So if the reaction is between zinc and copper, okay, so you have to write the reaction at anode and then the reaction at cathode. So supposing there is a reaction, the reaction is Zn plus CuSO4 giving ZnSO4 plus Cu. You have to write the cell representation of this reaction. So what is happening at the anode, Zn is changing into Zn2 plus. You have to write this double line which shows a salt bridge, and then the Cu2 plus changing to Cu, right? So this is the oxidation half of the cell, oxidation half, and on the right side it is the reduction half. Okay, and I have told you a few words to remember. You should always remember an ox and red cat. Okay, that means at cathode it is always reduction and at anode it is always oxidation. So if the two reduction potentials are given to you, SRP is given, standard reduction potentials are given to you, then the one which is higher SRP, higher reduction potential, right, will always become the cathode. Why will it always become the cathode? Because the one which has higher reduction potential will get reduced easily, and one which has lower reduction potential will become the anode. Okay, and then you should calculate the E0 cell, and E0 cell is always what? E0 cathode minus E0 anode. That is for the standard cell. When is it a standard cell? When the concentration of this is 1 molar and the concentration of the other one is also 1 molar. Okay, so if both have concentration 1 molar, then you can directly find out what is the reduction potential of one and the other, which will be given to you, and based on that you can find E0 cells. So that is the first part of galvanic cells, to find the EMF of the cell using this formula. Once you know the E0 cell, you can also find delta G0, which is equal to minus N into F into E0. Okay, N into F into E0. What is that? That is N is the number of electrons which have changed. In this case, the number of electrons which has changed is equal to 2. F is 1 Faraday. Value of Faraday will be given in the paper, but if it is not, you should know 1 Faraday is equal to 96500 coulombs. Okay, so that is a charge on 1 mole of electrons. So you can, using this value, you can also find minus NFE and find out the delta G. Now, if your values are not the same, if your it is not a standard cell, then what is the next thing that you should do? You should do Nernst equation. Nernst equation. So what is a Nernst equation? Nernst equation, you have to remember, it is E cell is equal to E0 cell minus 0.059 by N log of product raised to A divided by reactant raised to B. In a balanced equation, the stoichiometric coefficients are A and B. P is the concentration of the product and R is the concentration of the reactant. So in the same reaction, if which I had given earlier, Zn changing to Zn, not 2 here, here is only 1. So Zn changing to Zn2 plus and Cu2 plus changing to Cu, if it is the same equation. And here it is 0.00, it is 0.01 molar and this is 0.02 molar, right? Then what will be the this one? It will be E cell. For this reaction, E cell will be E0 cell that you would find out from the values which are given to you, minus 0.059 by N, which is 2, log of product. What is the product in this reaction? Hello? What is the product in this reaction? Product in the reaction previously you saw. It is, you should write the ionic equation. So, Zn giving Zn2 plus 2E minus and Cu2 plus 2E minus giving Cu, right? So what is the overall reaction? Zn plus Cu2 plus giving Zn2 plus Cu, right? So what is the product? Product is Zn2 plus. So what is the concentration of Zn2 plus? 0.01, right? Divided by reactant is copper, that is 0.02. And raised to 1 in both cases because it is in balanced equations, stoichiometric coefficients are not there. So you can find E cell. So E cell is found when your reactant, when your concentrations are not constant, are not 1 molar. Okay. So that is part 1. Okay, now in the part after this, you start talking about the second part, and that second part has all half of it is physics, so it will be easy for you. So you have to talk about resistance and conductance, specific resistance and specific conductance. So what is it? The formula we will just take first specific resistance, or so first is resistance, which is R, and it is measured in ohm. Then you talk about conductance, which is
G,
1 by R, G. You can call it G, and it is measured in ohm minus 1. Then you talk of specific resistance. Okay, what is specific resistance? It is the resistance of the wire which has, so resistance is proportional to the length of the wire divided by area of cross section. Then R is equal to rho into L by A. And rho is equal to what? R into A by L. Okay, so that is specific resistance. Then what is specific conductance? Specific conductance, also known as conductivity. Conductivity. It is measured in kappa, and that is equal to 1 by rho. Okay. So what
sigma,
is
ma'am.
1 by rho? We call it
Sigma, ma'am.
kappa. No, not sigma, kappa. You call it kappa, K.
Ma'am,
It is
in
written
physics, we have read it as sigma.
Okay, in physics you may be saying, yeah. So in chemistry you call it kappa because you convert it into, because you use concentration. So what is conductivity? Specific conductivity or specific conductance is the conductance of all ions present in 1 centimeter cube of the electrolyte. Okay, so 1 by rho. So it will, you can write it as is equal to 1 by R into L by A. L by A is known as the cell constant. For an electrolytic cell, it is a cell constant. Okay. Cell constant. So let me write on another page. The most important equation here is kappa is equal to 1 by R into L by A. L by A is cell constant. Okay. And what is the unit of kappa? It is ohm minus 1 and centimeter minus 1. ohm minus 1 and centimeter minus 1. Just right. So all these questions will be based on all these formulae. Then you have molar conductance. Molar conductance is 1000 into kappa by molarity. 1000 into kappa by molarity. So if I know, first you will have to calculate kappa using resistance, which will be given in the question paper. And cell constant will also be given. So first calculate specific conductance, and using specific conductance, you can find out the molar conductance. So molar conductance here. Then the next thing is that specific conductance, it decreases with dilution, but molar conductance increases with dilution. So specific conductance decreases with dilution. Decreases with dilution. And molar conductance, it increases with dilution. So these are questions which are sometimes asked in MCQs. Then the next important thing that we molar conductance at infinite dilution. Okay, so if I know molar conductance at infinite dilution, then I can find out the degree of dissociation. So alpha is equal to molar conductance upon molar conductance at infinite dilution. So this is another formula that you may use while you are doing the reaction. So we have already done 5 formulae. I will write them together once. The next thing is electrolytic cell. Electrolysis. So in electrolysis, there are 2 formulae. First, Faraday's first law. What does Faraday's first law say? Weight of the substance deposited at the electrode is equal to Z into I into T. What is Z? Z is the electrochemical equivalent. I is the current and T is the time. Okay, what is Z? Z is equivalent weight divided by, I have told you an easy way of doing it. You can write it as atomic mass into I into T divided by valency of the atom which is deposited into 96500. So that is how you find the weight of the substance deposited. Second formula that we have to use is if the same amount of current is passed through different electrolytes, then the weight of the substances deposited are in the ratio of their equivalent weights. Okay, W1 by W2 is equal to E1 by E2. Now E1 equivalent weight, what is equivalent weight? E equivalent weight is equal to the molar mass divided by the valency factor. We call it a valency factor. So what is a valency factor? It can be the valency itself, or it can be the displaceable H plus ion if you're finding the equivalent weight of an acid, or it can be replaceable OH ions in case of a base, or it can be the charge on the ion in case of a ionic compound. So you can find the equivalent weight, and based on that you can do these questions. So there are altogether
First formula.
which formula? The first one.
Yes, ma'am.
Okay, I'll explain the first formula. See, how to do this question is you have to first understand that in case supposing I have to discharge sodium ion, 1 sodium ion. How many electrons will I need? 1 electron, right? So 1 electron and it will become sodium. So for sodium ion to change into sodium, I need 1 electron, right? If I want to change Fe2 plus ion into Fe, I will need 2 electrons, right? If I want to change Al3 plus, then how many electrons will I need? 3 electrons, right? 3, it will give Al. Now, if it is 1 mole of sodium ions, so if I take 1 mole of sodium ions, how many electrons I will need? 1 mole. And then I will deposit how much? 1 mole, right? What is 1 mole of sodium? What is the mass of 1 mole of sodium? 23 grams, right? So in order to deposit 23 grams of sodium, I will need how much charge? Charge which is equivalent to the charge on 1 mole of electron. So charge on 1 mole of electron is equal to how much? It is 1 Faraday. 1 Faraday. 1 Faraday is what? 1 Faraday is equal to 1.6 into 10 raised to minus 19, which is the charge on 1 electron, into 1 mole of electron, 6.02 into 10 raised to 23. So if I do this, it comes to 96500 coulombs. So 1 Faraday is equal to what? 1 Faraday is 96500 coulombs. So 1 Faraday will discharge how much sodium? 1 mole of sodium. 1 Faraday will discharge 1 mole of sodium. Okay. Now here, if I want to discharge 1 mole of iron, 1 mole of iron is how many grams of iron? It is 56 grams of iron. But to discharge 56 grams of iron, how many Faraday will I need? I will need 2 Faraday.
Farad.
Right? If I take aluminium, how many Faraday will I need to discharge 1 mole of aluminium, 26, 27 grams? I will need 3 Faradays. How much will I need? 3 Faradays. So I need 3 Faradays for 27 grams, 2 Faradays for. So how many Faradays I need, or what is the total charge I need, depends on the charge on the ion. So if the charge is 3, I need 3. If the charge is 2, I need 2 Faraday. If the charge is 1, I need 1 Faraday. Okay. So, so what can I say? I can say 96500 coulombs discharges how many grams? 23 grams of Na, right? So 1 coulomb will discharge how much? 23 divided by 96500. Okay, grams of sodium. If I take, say, 96500 into 2 coulombs will discharge how much of iron? 56 grams of Fe. So 1 coulomb will discharge how much? 56 divided by 2 into 96500 grams of Fe, right? Supposing it is aluminium, 3 into 96500 coulombs will discharge how many? 27 grams of aluminium. So 1 coulomb will discharge how much? 27 divided by 3 into 96500. So for any, if I want to make it general, 1 mole of 1 coulomb of charge can discharge how much? It can discharge the molar mass of the substance divided by the valency 3 into 96500. So this is one part. Now to understand the first law, what does the first law say? The first law says that the weight of the substance discharged at an electrode is proportional to the amount of charge that is passed through the electrolyte. How much charge you pass through the electrolyte, that decides how much is discharged. So what I can do, I can remove the proportionality sign. I can write W is equal to Z. And what is Q? It is the current, that is I in amperes, and for what time you. So I into T is equal to Q, that you know from physics. So I want to find the value of Z. What is Z? If I is 1 ampere, 1 ampere, and T is 1 second, time is 1 second, then what will W be equal to? W will be equal to Z. And what will be the definition of Z? Z is the mass of substance deposited when 1 coulomb of current, 1 coulomb of charge, not current, 1 coulomb of charge is passed through the electrolyte, is passed through the electrolyte. Okay, 1 coulomb is how much? 1 ampere into 1 second is 1 coulomb. So if when I pass 1 coulomb, what is the mass that is? So I have just found a general formula for coulomb. What is the amount of substance which is deposited by 1 coulomb of charge? 1C is deposits how much? Molar mass of the substance, atomic mass or molar mass of the substance divided by valency into 96500. So in this formula, if I put that, what does W become equal to? W becomes equal to atomic mass or molar mass into I into T divided by valency into 96500. So you can, so why I did this, gave you this formula is it can easily, otherwise for each time you have to calculate the value of Z, and using the value of Z you have to substitute here and find out. Okay, if you want I can I don't know how to send you now, so I can send you a few questions if you want, like a test, and you can try them out. Okay, so to whom should I send? I don't have your email address or anything, so I can't send you. I can show you and wait for a few minutes. You can try them out. Just 1 minute. See, all these MCQs I have done with you. There is no MCQ of this which I have not done with you. All of them I have done. Now here, these are the type of questions which you should know. Like these are from your book only. How much charge is required for following reductions? So 1 mole of Al3 plus 2 Al. How much charge do you need? 3 Faraday. How much Cu2 plus 2 Cu? How much charge do you need? 2 Faraday. MnO4 minus to Mn2 plus. How much charge will you need? Now tell me, Sai Kalyan, how much charge will you need?
5 Faraday, miss.
5 Faraday. Why? Because here it is, here, did you understand why? Because here it is, Mn manganese is in plus 7
7
oxidation
plus 1.
state.
It
Then
will be plus
resistance of a
7.
conductivity cell containing 0.001. MnO4 minus is Mn is plus 7, isn't it? Oxidation state of manganese is plus 7. Can you make out that? See, I will show you. See, MnO4 minus. Okay, so what is it? Manganese, I don't know. So X oxygen is minus 2 into 4 minus 8 is equal to minus 1. So X is equal to how much? Plus 7. So here it is plus 7 changing to plus 2. So how many electrons? 5. So 5 Faraday. All right. Here Cu2 plus 2 Cu. How many electrons? 2. So 2 Faraday. Here Al3 plus 2 Al. How many? It is 3. 3 to 0. So 3. Here 2 to 0. That is 2. Here 7 to 2. How many? 5. So it is 5 Faraday. Did you understand?
Yes, ma'am.
Then the next is resistance of a conductivity cell containing 0.001 M KCl. And this is the resistance which is given to you. Cell constant. What is the cell constant? Okay, so conductivity is already given. The resistance of a conductivity cell containing this much. So you have to calculate conductivity, go backwards. And from conductivity, you will have to, what is the cell constant? If the conductivity is given. So if conductivity is given, what is it? Kappa is equal to 1 by R into L by A. What is L by A? It is the cell constant, right? So you know R and you know K, then you can find out cell constant. So like that, from there you can calculate. Then this is a reaction with where your SRP of chromium and iron is given. Mention the overall cell reaction and calculate E cell. Is it a spontaneous reaction? If the value of EMF of the cell is positive, then it is a spontaneous reaction. Here already the cell reaction is given to you. This is left side is the anode and the right side is the cathode. And you have to find out the E cell first, E0 cell. E0 cell, the standard reduction potentials are given. Using that, find E0 cell. And from E0 cell, using Nernst equation, you find E cell. Then this is molar conductivity of aluminium and these ions are given. Calculate the molar conductance of aluminium sulfate. What is aluminium sulfate? Al2SO4 thrice. So how will you find molar conductance? 2 into molar conductance of aluminium ions plus 3 into molar conductance of sulfate ions. Okay, so sulfate ions is given and aluminium ions is given. You just multiplication and addition, there is no problem. Calculate the degree of dissociation of acetic acid. Alpha is equal to this by molar conductance at infinite. So you can find infinite. How will you find this plus this? You first find molar conductance at infinite, add acetate ions and H plus ions, you will get this. Molar conductance is given already, you find alpha. So like that, simple questions. Electrochemistry is actually not very difficult. You have to just go through it. Do you get some notes also? Are you given some notes for studying?
Yes, ma'am.
So you go through the notes and also you go through the PPT that my PPT, they must have uploaded the PPT. So go through the PPT and then you should be able to do. All questions are from the textbook only, nothing other than textbook. So you should be able to do it easily.
Ma'am,
Okay.
can you explain the 10th question and 6th question in the exercise?
10th and 6th. Just 1 minute, I'll get the book. Tenth and 6th. How do I know that it is given as 3.6, 3.8, 3.10?
Yes, ma'am.
So you leave the 10th question. That question as of now for tomorrow, you don't worry. In one of the classes, I will explain. Anyway, the question here, there is sometimes you have to draw a graph. The graph is between concentration, square root of concentration, and here it is molar conductance. So if the graph is like this, like a straight line, then this graph is showing the effect of dilution on strong electrolytes. In case of strong electrolytes, molar conductance does not change much with dilution. But if it is a weak electrolyte, the graph is like this. So this graph, this one is for a strong electrolyte, this one is for a weak electrolyte. Okay. So as of now, this graph question is not there, so you don't worry about it. But yes, I will explain to you how to draw this graph. In one of the classes, I will download a graph paper and I will show how to do. But basically, you have to only understand which is a graph for a strong electrolyte or a weak. So you have to plot the graph. If the graph is a straight line, almost straight line, it is a strong electrolyte. If it is a line which does not meet the y-axis at all, then it is a weak electrolyte. Then which is the next one you said?
Ma'am,
11th
6th one, ma'am.
6th one. in button cells and watches, following reaction takes place, determine delta G and delta E for the reaction. So let me write down the reaction for you. Zn solid plus Ag2O plus H2O giving Zn2 plus 2Ag plus 2OH minus, right? So you have to write, how will you write the cell reaction? You will write the cell reaction is Zn2 Zn changing to Zn2 plus 2E minus. You can write, simplify it. And here, what is the oxidation state of silver? Ag plus. So Ag plus E minus is giving Ag. Okay, now multiply the second equation by 2. So it will become 2Ag plus 2E minus giving 2Ag. Right? So what is the overall reaction? It is Zn plus 2Ag plus giving Zn2 plus 2Ag. Anyway, even if you don't balance, you can make out what is the anode and what is the cathode. So where is oxidation taking place? This is oxidation. And where is reduction taking place? This is reduction, right? So what is reduction will be the cathode, and what is the oxidation will be the anode, right? So what will be E cell? E0 cell will be equal to E cathode minus E anode. Right? Now, E cathode, the values will be given to you, although they are not given here. I can tell you the cathode is the silver. So for silver, it is 0.80 volts. This will be given in the paper. And what is the reduction, oxidation, what is the reduction potential of the anode? It is minus 0.76. So it will become 0.80 plus 0.76. So it will become 1.56 volts. Okay, so for mercury cell, the EMF of the cell is 1.56 volts. Did you understand, Vaishnavi?
Yes, ma'am.
I think the paper is not difficult. I don't remember the paper, but I don't think it is a difficult paper. It's easy. Don't worry, you will be able to do it. I have almost discussed, if you go through the PPT, you will realize all the questions are discussed in the class, directly or indirectly. Okay? All the best.
Yes, ma'am.
Don't worry, you will all do well. Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye, Kalyan. Any doubts, any more doubts that you have?
No, miss, no, miss.
Okay.